Okay, guys, we are starting off right off the bat here with statistics. This is statistical reasoning, the block class, and so I'm obviously not here for the first few days with the birth of our son. So you'll be watching these videos that I've recorded and taking notes along with it, and then just going about just a normal classroom. So we want to start with some of you might have been through this class before. Some of you might have taken it last semester. Some of you are coming from other classes, but we want to start with defining what statistics just really is. And what statistics is, it's the science and the art of collecting, analyzing, and drawing conclusions from data. And so that's what we're going to be dealing with for the next semester here is a lot of data. We're going to learn how to collect the data, really learn how to analyze it, and then the last thing will be drawing your conclusions. And that leads us really to what our four-step statistical problem-solving process is, guys. And what that is simply there's four steps to that. And our first step, when we're trying to do a problem-solving process, is we have to have a question. So we want to ask some type of question. That's really why anybody does any type of research is because they have a question that they want answered. And that question might be studying a quantitative variable or a qualitative variable, and we'll get into all that later. But in order for this whole thing to kick off, you got to have a question that you want answered. Then after that, what you'll do is you'll collect your data. And we're going to talk about a lot of different ways to collect our data, a lot of different types of surveys, observations, experiments, and so forth, and we'll get into all that. But once you have a question, then we need some data to look at and to analyze, and the analyze is the third step. So we analyze the data, and we'll get into methods of analyzation, uh, from linear regression to exponential regression, depending on what the data looks like. All kinds of different things, chi-square distributions. We'll get into all that and talk about how to analyze the data, whether it's just a simple five-number summary, whether it's a box and whisker plot, a dot plot. We'll look at the skewness of it, the shape of it, where's the center. All those things come into play when we start analyzing our data, and we'll get into that. And then from there, once you've analyzed it, you need to be able to interpret your data. Okay, you need to be able to interpret your data. So it doesn't do you much good if you go through and you have a question that you want answered and you collect your data and you analyze it right, but if you don't know how to interpret it, you're really kind of wasting your time there. So that's a big step, is being able to interpret and draw conclusions from our data, and also being able to present those conclusions and interpretations to others. That's why we do statistical research, is to answer questions and to inform everybody else about what we have found. And so if you can't interpret it and you can't disclose what you found, then you're kind of wasting your whole time. So really step number four is the biggie right there. Okay, so when you start your statistical problem solving, you start researching and things, most of the time what you're going to do is you're going to look at an individual or a group of individuals. And so what an individual um, is nothing more than a person, animal, or a thing described in a set of data. And so we'll have a group of individuals. Sometimes it'll be 30 individuals. Sometimes it may be 500 individuals, maybe 1,000, depending on what our study is and how big our sample size is. Um, and then what will happen is we'll be taking those individuals and we'll be looking um, at variables that describe those individuals. Okay, and that variable is any attribute that can take different values for different individuals. And so we'll look at some different variables, and those variables are what you're measuring, whether it's weight, whether it's age, whether it's hair color, eye color. Could be your sex, whether you're male, female. Could be educational status, how high did you go. Could be socioeconomic status. All those things are variables that you can study. And what we'll do is we'll talk about two main types of variables that we have. One is categorical, one is quantitative. And categorical is any value that can take on a label that describes like a group of individuals or a whole group in itself, or simple individuals, but they're labels that place each individual into a particular group or simply a category. And so your categorical variables are things that don't have numerical values. So like eye color. If I ask you what's your eye color, you're not going to tell me 7. You're going to tell me green. You're going to tell me brown. You're going to tell me blue. Another one might be what is your highest educational level. You're not going to tell me 6. Okay, you're going to tell me, hey, I have a bachelor's, or hey, I have a master's, specialist, doctoral degree. It could be something as hair color, blonde, black, brunette, brown. Okay, so all those things would be categorical variables. And on the flip side, you can also have quantitative variables, and quantitative takes on a numerical value. So it takes anything that gives you a number value, and there are quantities and there are counts that put you in numerical values. Okay, and so that would be something like, hey, what's your age? How much money do you make in a year? What's your weight? What's your GPA? All of those things are what we call quantitative variables, and most of your statistical studies are quantitative in nature. Although there are, especially in education, a lot of categorical variables that we can study, but most of your studies in statistics take on a quantitative nature. Okay, and a lot of the studies we'll be doing in here will take on quantitative nature as well. So what we're going to do here, we're going to look at this data, and what we're doing is we're looking at PG-13 movies of all time. So the top uh, opening widest domestic PG-13 movies of all time, measured by number of theaters. Okay, so we have how many theaters these movies premiered in. And so you see also too, we have the distributor who put out the movie, opening weekend gross, so how much did they make, and then what type of genre is it. So we want to first look at the individuals and the variables for this data set. So our individuals are going to be simply the 5 movies that we have here. Okay, so if we look at it, everything that I'm highlighting in red here, those are your individuals. That's what we're studying. They're taking on variable values, but the individuals are your 5 top movies. Now, the variables are going to be those those values that we looked at for each one. So the 4 variables that we have, if you look across that top, the 4 variables that we have are theaters, distributor, opening weekend gross, and finally genre. Those are the 4 variables that we're looking at here that describe each of the individuals. Now we want to take those and we want to classify them as to whether they are categorical or quantitative. Now remember, categorical is a label. Quantitative is numerical in value. Okay, so categorical would simply be something that takes on a label. So that would be the distributor. That would be the distributor, and that would be the genre. Those 2 things do not have numerical values in them, whereas the quantitative would be the number of theaters, and would also be the opening weekend gross. Whoop. And so you see right here, looking up here, again, theaters and opening weekend gross, if you look at the things that are in that variable, they're all numerical in value. So that makes them quantitative. Whereas the distributor and the genre are both have labels on them. Okay, so that's what makes them categorical there. So make sure we're good with identifying individuals, make sure we're good with identifying variables, and then also taking those variables and being able to describe them as either categorical or quantitative. All right, so if you look right there, there's a little bonus tip there. So, we talk about quantitative variables. Um, talk about quantitative variables being numerical in value and categorical having labels. Now, categorical variables um, can have numerical values, okay? And it gives you some examples here. So it can be house number, whatever your street address is, your telephone number, your social security number, and your zip code. Those are all still labels even though they are in numerical form. Okay, so just be careful there. Um, for a quantitative variable, the key part is that it has to be a count or a measurement in order to be quantitative. Okay, but those are some examples. So don't just get hung up on the fact that if you see a variable that has some numerical values in it, don't just automatically think that it's straight quantitative. Make sure, is it labeling something or is it counting and measuring something? If it's counting and measuring something, then it's quantitative. Okay, and so now what we're going to do next is we've talked about the variables and quantitative and categorical. Okay, we need to look at, well, how do we look at to see analyzed data? And the big thing we're going to look at to analyze data is going to be look at the distribution of the data itself. And what that distribution does, that tells you a lot. It tells you about where the center of the data is, tells you about the spread, tells you if there's any skewness, and we'll talk about that, where skewness is you got a concentration of data on one end or other of the distribution. Okay, and so what that does is that distribution tells us what values the variable takes and how often it takes these values. Okay, and so we're going to look at some really when it comes to this, we're going to look at either bell curves or we're going to look at dot plots. And dot plots are really good for telling us how often it takes these values here. Okay, but also too, what we can look at is we can look at when we're trying to analyze data is look at a frequency table. Okay, and this is great for being able to analyze data. What a frequency table does is it shows you the number of individuals having each data value. Okay, so similar to a dot plot, but it's not a plot, it's simply a frequency table. So it shows you the number of individuals having each data value. And then also that goes along with it, the relative frequency table will look very similar, will have the same individuals, but instead it just shows the proportion or percent of individuals having each data value. So that's when it takes the numbers from the frequency table and divides them by the total, and then what happens is you have a frequency table that looks similar to the normal frequency table, but it has percentages and it has decimals instead. Okay, so what we're going to do is Ms. Mosher is going to pause this video for a minute, and what we need you to do is to go through and we need you to count how many of each of these comedies you have. So you see down here on the left hand side you have your frequency table. Notice on the left hand side of the frequency table are all your labels, your preferred genres. What we're going to do on the right is we're going to give you a few minutes and we want you to count how many action movies do you have, how many animation movies do you have, how many comedy movies do you have. Okay, and then she'll unpause it after you've had a chance to do that, and then I'll talk you through how to do the relative frequency table. Okay, so after going through and counting these out, okay, you should have gotten that the action, there was a count of 12. Animation, we had a count of 1. Comedy, there was a count of 5. Documentary, there were 2. Drama, there were 6. Horror films were 6. Rom-coms were 4. And sci-fis were 4. Okay, so if you add those up, Okay, it told us we had 40 to start with. Let's make sure we add those up and get 40. 12 and 1 is 13. 18, 20, 32, 36, and 40. So we got a total of 40 there. And the reason I'm talking about the total, one, to check to make sure we didn't miss anything, but secondly, I'm going to need that total to do a relative frequency table. So again, all you did for the frequency table was to simply count up how many you have in each one right there. And then from there we were able to just create our frequency table where the individuals are listed on the left, and then the count is listed on the right. Now, in order to do a relative frequency table, okay, that's why we figured out the total. It's going to be a proportion or a percentage to the whole. And so the total was 40 here. So what we'll do to come up with a relative frequency table is, remember there were 12 action movies. So what I'll do here is I'll say, okay, well, let's do 12 divided by 40. And we can leave these as a decimal, or, which is 0.3, or we could say 30%. But to create a relative frequency table, all I'm doing is I'm simply taking each number that's in the frequency table and dividing by the total. Alright, and so that means I'm going to do 1 divided by 40 here, which is going to be 0.025, or if you prefer a percentage, that's 2.5%. Comedy, there were 5, so we're going to do 5 divided by 40, and that ends up being 0.125, or 12.5%. Documentary, there were 2 divided by 40. Notice I'm always dividing by 40 because that's the total. That ends up being 0.05, or simply 5%. 6 divided by 40 is going to be 0.15, or 15%. Same thing there for horror. It was 6 divided by 40, which is 0.15, or 15%. Rom-com, that was 4 divided by 40, which is 0.1, or simply 10%. And then finally we got 4 divided by 40 again, which is still 0.1, or 10%. Now, when you're done with your relative frequency table, you should be able to add up these percentages, and it should add up to 100%. Okay? So we get, let's see, 15 and 30 is 45, 50, 65, 80, 90, 100%. Or if you're checking up the decimals should add up to equal simply 1. Okay, so again, 0.025 and 0.25 is 0.15, that's 0.45, and then you continue on, we do end up with 1. Okay, so when you're checking your relative frequency table to make sure you did it right, okay, all you need to do, add up your decimals to get 1, or add up your percentages to get 100. Okay, so there your relative frequency and your frequency table. Frequency table comes first. You figure out what that total is, and then from there, to figure out your relative frequency table, all you have to do is take the frequency count for each category, each individual, and divide it by the total to get the relative frequency.